Yeah, okay. I think this is yes. So I'm Andreia Sousa. I'm a data scientist and Scrum Master at Basecone. I'm a member of Data Brewers team. Is the data science team. The name of my team is Data Brewers. Okay, I already work with retail companies, banking sector, and develop business intelligence and machine learning solutions, helping solve business problems and supporting informed decision making on these companies. Okay, our agenda for today is I will speak a bit about the document entity extraction context on Basecone, machine learning approach, our machine learning approach for this problem I will to present you. Algorithm research work and information extraction steps. Okay, please guys feel free for interrupt me and make some questions. So I don't know if you know the Basecone. The mission of Basecone is give back time to the accountant, because the Basecone is application, a financial application. So to give you some context, imagine we have a city with a lot of companies, city institutions. Okay, these institutions has a lot of documents, and they need to archive these documents and present these documents to the government. So for that, Basecone think we need to have a place where people need to have all these documents, okay? And so the city have this lot of documents. The Basecone process documents and extract document entities. For example, bank entities, bank accounts, about the contracts, intervenient and contract type, on bills, amounts of the bill and the type of services. This is the objective of Basecone app. Other information other important information we can find on invoices, customer info, billing date, read date, usage, total charge. This is the example to clarify all this, okay? So process documents and extract document entities, it's a lot of manual process and time consuming. So what our problem? We need to, how do we parse this automatically and save this info? We need to give quality time to accountant to stay with family, to do another things with friends, okay? Not to pass all the time to collect information from invoice and put on application. The idea is to create an automation system and an analytics system. So we have the invoices, we will create an entity extractor system. After that, we will have a table with all important information. And with this table, the accountants can do dashboards, forecasting for next months, to analyze data, to predict some data, to improve our work and improve the quality time. So our machine learning approach, the machine learning life cycle, we need to define the problem and what the solution. We already did that in previous slides, okay? Get data. I will to explain how we will do that. Perform exploration data analysis, sorry. Prepare the data to our algorithm, define the network, train our network, deploy this network. Obviously, we will train and train and train, okay, find the best solution, deploy this solution, and after that, document and present solution and maintain this solution on system, okay? How we will do the data collection, okay? Machine learning models need high amounts of quality data, okay? Quality data is not data. We need the quality data. There is the need to annotate the data by human crowds. So we have the invoices, but we need to give some information, the algorithm, where is the important fields, okay? So we need to do some steps to collect this data. Set up crowd of annotators, instruct them about the task, get labeled data, validate annotated data, and get data for ML models. So we hire for companies to do these annotations on invoices. So the objective of this is looking to invoice and draw a box around the important information. For example, around the total amount, around the invoice date, around all important fields. Okay, so this way we will create our data set. We will train with this data set. We will give to algorithm where it is our important information. Okay, so we hired a lot companies and worked with these companies to create our data set, our annotations. So the idea is the business analyst provides data literacy. We have a crowd, label the documents, and we have a database with labeled data. Two keynotes about this process. Annotators should have a clear understanding how the document should be labeled, okay? Because we need to good annotations. Bad quality data leads to unperforming models. So we need quality data, but we found some challenges during this process because we found a lot of documents with bad quality. So dirty images, strange orientation of the pages, bad quality. So this here we can look a lot of examples about that bad quality of images, okay? So during this training data, we need to deal with low amount of data, remove images with low quality, remove rotated images, that image with the strange orientation, and remove receipts, because in our first approach, we will only deal with invoices, not receipts, okay? So we remove the receipts from our data set. Okay. After that, after we have our data set, the data science team has been working on two approaches for trying to find the best approach for this problem, or a text approach or image approach to extract this information from invoice. So we found the SHA-GRID method is a mixed method, not entire text approach, but is a text and image approach. If you look to the images on slide, in first image you have an invoice, version invoice, okay? In second image you have an invoice with colors, is SHA-GRID to color the different characters, okay? In third image, you have the lines, the box around the lines. And in fourth image, you have the SHA-GRID representation. Each character has a different color, okay? And all important information in invoice are color, has a different color, okay? So SHA-GRID is a 2D grid of characters. We have a document. After that, text extraction with OCR engine. After that, we have characters and character bounding boxes created by SHA-GRID. So in SHA-GRID, we will have characters, words, line, and important information. Okay. How we extract our ground truth? We have the document annotations, and SharGrid we will provide the segmentation mask. In segmentation mask, we will see, for example, the first blue, you have suppliers. So in image, you can see the same color. This color in image, the segmentation mask in image is the supplier. About the date is the same. The segmentation mask related with the field date has another color. The line in segmentation mask has a color green and the amount has a color red. Okay. After that, we will do training and here we have the model architecture. So we have car grid. We will grid extraction information. We have the pre-processing methods. We will apply the on-note encoding. After that, we will run a neural network with two tasks, a semantic segmentation to predict pixelized and scalar class, and bounding box regression to predict lines on the document. In the end, we will have a segmentation mask like you see on previous slide. Okay. Only our SharGrid is only the method to extract information from invoices based on text and image. Okay. After that, we will have a neural network with a semantic segmentation. Okay. Our optimization function here, for binary problems, we use a sigmoid function. For multi-class problems, we are using a softmax function. Okay. For loss function, we used the binary cross entropy plus dice loss. Okay, how we will to extract this information? Because in the end, we have a prediction mask. So we have SharGrid, we run deep learning model, we obtain the prediction mask. And so we need to extract text inside of each segmentation mask. So we need to intersect between word grid with the prediction mask and understand what value we have inside text extraction. Okay, inside segmentation mask. Because on word grid, the document we can have after OCR bounding boxes and text, we have the text, the real text. And on prediction, we have a mask with a dimensions of box and a position. For evaluate our results, we can use the word error rate and fuzzy metrics. On this presentation, I will show you the results for fuzzy metrics, okay? So for when you run to subtotal amount, VAT number, customer address, IBAN, customer number, invoice date, and total amount, we have a fuzzy score or accuracy, number of correct prediction divided by number of samples in this analysis. We can see a good performance. The better performance is for total amount, okay, for field total amount. But for customer number, invoice number, and invoice date, the performance is also so good, okay. We have around 85%, okay. So the inference time of our model is 6.01 seconds per document. So these results are so good because on this solution, the people don't need to put the important films, the manual work, don't need to use the manual work to put these fields on important fields. This algorithm put automatically these fields on correct field. Okay. So this is our problem and the work we have been developed until now on Basecone. Now we can do some questions. I don't know if someone has questions.
So first of all, can we see some claps and Andrea, that was amazing. It's a very hard subject to talk about, and there is a lot of steps. So actually be brave enough to do a presentation on that. Well done. Thank you so much.
The challenge is not to run the algorithm. The challenge is prepare the data and understand all challenge during the prep processing to prepare the data to run the algorithm. Okay, and if you have some suggestions or another idea, please let me know and share your idea with me and with our team. Okay.
Okay, so we have a question that I'm gonna put on stage. I'm just gonna translate the question for anybody who's coming from abroad. So in a neuronal network, what are the number of neurons used, more or less, and layers, intermediary layers in the network? So Andrea, feel free to answer this because I have
we have a lot of experiments with a number of neurons. Okay, I'm not sure about the number of neurons on this experiment. Okay, but I will check and maybe on table I will answer you. Okay, with more precision. Okay. Because I don't have sure about this experiment, and I want to answer you with correct information. Okay.
Cool. So that's good. So we have another one that I'll show on stage. Please, João, talk to Andrea on the table. And the next question is, why use neural networks instead of other options?
Okay, we and classification algorithms, but we don't have, this problem is a complex problem. We need to use deep learning to have a good answer. Okay, we need to deal with overfitting. Okay, I don't speak about this problem here, maybe on next presentation, but of all algorithms we tested, the best results we have using the neural network. So neural network was the best option for these problems. We read a lot of state of art also, and if you check, we have this type of problems in the most of literature, the people using the neural networks. So we using this also, because the problem, the part of data preparation is so complex, so we need to maintain the algorithm easy, to pay more attention on part of pre-processing data and data preparation on this part. Okay.
Cool. So thank you, Carlos. And if you want to have a little bit more of a discussion, please engage with Andrea, have a chat with her. May that be now or in the...
Okay, let me say one thing. We tried the RNN problem and invoice.net problem. If you search on Google, you can see papers related with this. Okay, is a recent papers on literature, but you can see other approaches with RNN and invoice.net.
Cool. So yeah, I think we're getting to the 20-minute mark. So, there's another one.
Okay.
Okay, so last question. Your models were developed for a specific set of document structure. Will they work for other structures? How large is the annotated data?
Okay, it's a good question. Okay. We have lots of invoices, the different from different countries. Okay, we try to pick different templates, different formats for training the algorithm for algorithm learn to deal with all templates we have. Okay, because our client is not a new client every day. It's old clients, so a lot of templates. We have more than 100 templates for each client. But yeah, we need to improve the algorithm for new templates appear on our algorithm. This problem is very difficult to deal with new templates in our training data set. Yeah. We create a data set with different templates from different countries with different languages, but at the moment, our algorithm works well for Dutch and English. Okay, for other languages, we need to improve more. And yeah.
Okay, cool. So yeah, please feel free to keep on asking Andreia more questions after the event. And once again, thank you, Andreia, for taking the time. That was awesome. And up next, we're going to have Tai Kai. See you in a bit.